Hello and welcome to all students. In this lecture we learn about determinants and we study the concept of linear dependence and independence. So first of all we see the definition of linear dependence. The n vectors v1, v2, vn in Rn are said to be linearly dependent if and only if the determinant of the matrix whose columns are v1, v2, vn is 0. So the definition is very simple. So this is the definition of linearly dependent vector. Okay, so for given n vectors we form a determinant with columns are these n vectors, and if this determinant is 0 then we say that the vectors are linearly dependent. So let us see the next definition. Definition of linearly independent vectors. And if the determinant is non-zero, then we say that the set of vectors are linearly independent. Okay, so these two definitions are very simple. Let us see one result now. If in the set of vectors v1, v2 up to vn at least one vi is equal to 0, then the whole set of vectors is linearly dependent. This is the one important result that we will use in while solving the examples. Let us take the next result number 2. Two vectors v1 and v2 are said to be linearly dependent if and only if one of them is a scalar multiple of other vector. Okay, that is also important, and let us solve some examples based on this now. So first example, check linear dependence and linear independence of the following vectors. So let us take one example. First example, vector v1 is 1 comma 1 and vector v2 is minus 3 comma 1. So to check linear dependence and independence, let us consider the determinant whose columns are these vectors. So consider determinant whose first column is 1 1, second column is minus 3 2, and is equal to, let us expand this determinant, and it is 1 into 2 minus 3 into 1. So 2 minus plus, and it is 3. So 2 plus 3 is 5, and 5 is not equal to 0, means determinant is not equal to 0. Therefore vectors v1 and v2 are linearly independent vectors. Now let us take the next example. Vector v1 is equal to minus 3 comma minus 2, and v2 is equal to minus 3 comma 2. Now consider the determinant whose columns are these two vectors. First vector is 3, first column is 3 minus 2, second column is minus 3 2, and find the value of this determinant. So it is 3 into 2 minus 3 minus 3 into minus 2, and the value is 6 minus 6 and is equal to 0. Okay, so the value of this determinant is equal to 0, means the vectors, therefore vector v1 and vector v2 are linearly dependent vectors. So in this way we use the determinants to identify the dependence and independence of vectors. Okay, so let us take now next question. Let us take next question. Same question, check check linear dependence and linear independence of vectors. So first set of vector is given. Vector v1 is equal to 1 minus 2 1. Vector v2 is given minus 2 3 minus 3, and v3 is given 3 minus 4 5. Okay, so we have to check the linear dependence and independence of these three vectors. So let us form a determinant consider determinant of these vectors. So first column is 1 minus 2 1. Okay, second column is minus 2 3 minus 3. Next column is 3 minus 4 5. Okay, and let us find the value of this determinant by using Laplace expansion. Okay, and the value of the determinant is equal to 1 into bracket 3 into 5 minus 4 into minus 3 minus sign minus 2 into bracket minus 2 into 5 minus 4 into 1 plus 3 into bracket minus 2 minus 3 minus 1 into 3. So what we have is into first bracket 15 minus 12 plus 2 into bracket minus 10 plus 4 and plus 3 into bracket 6 minus 3 bracket complete. It is equal to, so this value is 3, first bracket value is 3 plus 2 into bracket it is minus 6 and plus 3 into bracket 3. So it is 3 minus 12 plus 9, and this addition is equal to 0. The value of the determinant is 0. Therefore vectors are linearly dependent. Okay, now let us take next question number 2. So set of vectors is given. Vector v1 is equal to 1 3 0. Vector v2 is equal to minus 1 3 6 v3 is equal to vector v3 is 3 5 minus 6. Okay, so to check the linear dependence and independence of these vectors, form a determinant and find the value of the determinant. So determinant first column is 1 3 0 minus 1 3 6 3 5 minus 6, and you will observe that the value of this determinant is minus 12 and it is not equal to 0, and therefore so try to find the value of the determinant at your own. The value will be minus 12 and it is not equal to 0, therefore vectors are v1 v2 v3. These vectors are linearly independent vectors. Now let us take now next question. Next question is okay, find the value of k for which the following vectors are linearly dependent. Find value of k for which the following vectors are linearly dependent. Okay, the set of vectors is given. v1 vector is 1 3 k, vector v2 is equal to 2 k 6, and vector v3 is equal to 3 5 8. So we write consider determinant equal to 0. So to check linear dependence, that's why we are considering determinant equal to 0. Okay, so consider determinant of these vectors. First column is 1 3 k, second column is 2 k 6, third column is 3 5 8, and it is equal to 1 into bracket k into 8 minus 5 into 6 minus 2 into bracket 3 into 8 minus 5 into k, bracket complete, and it is equal to left hand side and then 3 into bracket 3 into 6 minus k square is equal to 0. So we solve this left hand side, 8k. After solving this left hand side, we will get k square minus 6k plus 8 is equal to 0. And if we solve this quadratic equation in k, you will get the answer k is equal to 4 and k is equal to 2. Okay, so for these two values of k, the given vectors are linearly dependent. Okay, now let us stop our lecture here. Okay, so this is the end of our lecture, and thank you.